दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, last class I discussed with you the acid radicals, which I call as oxy anions. What is an oxy anion? When an element combined with oxygen forms an electronegative radical is called oxy anion. They are otherwise called as acid radicals, and we discussed about oxy anions are compound acid electronegative compound radicals. So just to brief you what I have told you last class, the elements they combine with oxygen, they form radicals, their name ends in ATE or ITE. All oxy anions, their name ends in ATE, ITE. If the element is using its higher valence state than the ATE state, then the name begins with a per, ends in ATE. And if the element uses its lower valence state and combines oxygen, then ITE, then the name begins with hypo. So there are 4 types of radicals. Oxy anions can be possible for an element: per ATE, ATE, ITE, hypo ITE. So let's take the group 17 or group 7A elements or group 17 halogen family. Chlorine combines the oxygen to form ClO4 minus, ClO3 minus, ClO2 minus, ClO minus. 4 radicals are here. So ClO4 minus, 4 oxygen, maximum oxygen is there, so highest valence state. Then 3 chlorate, 3 next, then chloride, then comes ClO2, then comes ClO1. So ClO4 minus was named as perchlorate, ClO3 minus chlorate, ClO2 minus chloride, ClO minus hypochlorite. And the other elements of the group 7 are bromine and iodine. So the elements belong to a group exhibit similar physical and chemical properties. So bromine and iodine also form same type of radicals: BrO4 minus perbromate, BrO3 minus bromate, BrO2 minus bromide, and BrO minus hypobromite. Iodine forms IO4 minus periodate, IO3 minus iodate, IO2 minus iodide, and IO minus hypoiodide. Then let's come to group 6. The sulfur, the group belong to group 6, and the group number, the charge on the radical will be 8 minus group number. So group number is 6, so 8 minus 6 is 2, so that will be minus 2. So sulfur forms combines oxygen to form 2 type of radicals, SO4 minus 2 and SO3 minus 2. So SO4 is higher, so sulfate, SO4 minus 2, and SO3 that is lower, so SO3 minus 2 is sulfite. So when an oxy anion combines the H plus and forms a radical, its name begins with bi. So SO4 minus plus H plus forms HSO4 minus is called bisulfate, and SO3 minus 2 plus H plus forms SO3 minus HSO3 minus is called bisulfite. These are the standard. Then comes the 2 other radicals the sulfur forms. One is thiosulfate, S2O3 minus 2, and another is tetrathionate, S4O6 minus 2. So here thio means again sulfur. The other name of sulfur is thio, S2O3 minus 2. 2 sulfur atoms are here, so thiosulfate, S2O3 minus 2, and tetrathionate, S4O6 minus 2. 4 sulfur atoms are there. Now coming to group 5. So here they will have the charge, then 2 elements: nitrogen, phosphorus, arsenic, antimony, bismuth. All these elements are combining the oxygen to form their oxy anions, and the charge will be 8 minus 5, that is 3, so they will have the minus 3. But here nitrogen is an exception. from this. So nitrogen forms two types of radicals, NO3 minus, NO2 minus. NO3 minus is called nitrate, NO2 minus is called nitrite. Then comes phosphorus, PO4 minus 3 is called phosphate, PO3 minus 3 is called phosphite. Like that, arsenic has through valence states, plus 3 and plus 5. So ASO4 minus 3 arsenate and ASO3 minus 3 arsenite. Then coming to group 4, we have discussed carbon and silicon. Carbon forms CO3 minus 2 carbonate and silicon forms SiO3 minus 2 silicate. And then again carbon as carbonate combines with H plus to form SCO3 minus, it's called bicarbonate. So these are the radicals I have talked to you, compound electronegative compound radicals in my last class. Now I am coming to the electronegative compound radicals found by the transition metals. Transition metals. So there are so many transition elements we are not going to discuss because we are discussing keeping our syllabus in our view. We are not discussing the radicals found by all the elements. So the 2-3 elements are there, we are concerned with them, and we will discuss about the radicals. Then using them we will get to how to write the formula of the compounds. So today's class generally mostly I am going to writing the chemical formula of a compound. Write the formula of a chemical compound. How to write the chemical formula? Only I will tell some few radicals, more radicals, then I will go to the how to write the formula of chemical compounds. Now coming to 6b radicals elements, if you go, we have two elements here, chromium and molybdenum. You have chromium 6b, D block, then come to molybdenum. So chromium 6 means here charge will be minus 2, 8 minus 6 is minus 2. So chromium forms CrO4 minus 2 and Cr2O7 minus 2. It forms two radicals, CrO4 minus 2 and Cr2O minus Cr2O7 minus 2. So it is this is called chromate, and there are two chromiums are, you see chromate, so there are two chromium atoms are here and this is called dichromate. So you see, here chromate and here also chromate. So why this? Question comes to my why this? Now you calculate, you will find the valence state of chromium in chromate is plus 6 and valence state of chromium, and this is also plus 6. Let us take in chromate, calculate and let us verify CO4 minus 2. Let us take the valence state of chromium is X. So this is CrO4 minus 2. So X, and oxygen is minus 2 into 4, that is 8, and that is equal to minus 2. So X will be plus 6. So chromium is using its plus 6 oxidation state. Now if I come to Cr2O7 minus 2, Cr2O7 minus 2, here this is Cr2O7 minus 2. So chromium I am taking X. So what will you here? 2X minus 14 is equal to minus 2. So X is equal to plus 6. So in chromate and in dichromate, the chromium is using its plus 6 oxidation state. So two chromium. So this type of formation is called polyacid formation. This is called polyacid formation. We will be reading when we will read acids, bases, salts. Then we will discuss about that. So here chromium form this. Then below chromium there is molybdenum. If you go to the 6th periodic table, I wrote to you last class, chromium, molybdenum, tungsten. These are the three elements in the 6b group of the periodic table. The elements are chromium, atomic number 24, then molybdenum, atomic number 42, and tungsten, atomic number 74. So here chromium. Then comes the molybdenum. So I told you what is a group? The elements belonging to a group have similar physical and chemical properties. Chromium, molybdenum and tungsten, they will form same type of radical. Since chromium is forming chromate -2, now let's come to molybdenum. So molybdenum will form MoO4 -2. This is called molybdate. My point is, children, you see, you will not remember the name. If you know once chromate, automatically molybdenum, molybdate. Then tungsten will form WO4 -2, tungstate. Tungsten, it is called tungstate. So how easy it becomes when you go to the periodic table and try to write the formulae, the radicals. You are not remembering. Many often you are asked by your teachers in the college or in school, remember the chromate CrO4 -2, chromate CrO4 -2. No, chromium belongs to group 6. It will form radicals, its charge will be -2, and it will use 6 valence plus 6 valence state because it belongs to 6B group of the periodic table. So hence I wrote very easily CrO4 -2 chromate, Cr2O7 -2 dichromate. And since chromium, molybdenum, tungsten, they belong to same group of the periodic table, molybdenum will form molybdate and tungsten will form tungstate. So where is the point in remembering? Where is the point? Where is the point in remembering? And those things which are necessary to us, let us find out a way how we can solve tricks. We will find out the tricks to solve our difficulties. Let us don't go by getting by heart them. Now I'll come to group 7B of the periodic table, where I have the manganese, atomic number 25. Manganese, atomic number 25. It is in the 7B group of the periodic table. So 7, it is a group 7. So 8 minus 7 is -1. 8 minus 7 is 1, and we are discussing about a negative radical, so -1. So manganese will forms a radical MnO4 -1. It is called permanganate. Permanganate. How? Now think, if you come to 6A group of the periodic table, chlorine forms, we have already done ClO4 -1 perchlorate. We wrote this perchlorate. So manganese group 7, chlorine group 7, chlorine forms ClO4 -1 perchlorate. Automatically manganese will be MnO4 -1 permanganate. And another radical, the manganese forms MnO4 -2. It forms MnO4 -2. It is called manganate. It is called manganate. It is a lower valence state of manganese. It is a higher valence state of manganese. If you come to this manganese, if you take manganese MnO4 -1, so you take a manganese as X. So X minus 8 is equal to -1. So X is +7. If you go to chlorine, here also, if you come to chlorine, X minus 8 is equal to -1. X is +7. So chlorine is using its +7 oxidation state perchlorate. Manganese is using its +7 oxidation state permanganate. Now coming to MnO4 -2. Why this name and how this name comes? MnO4 -2. So X minus 8 is -2. So X is +6. X is +6. So here you have a new oxidation state which is not forming by chlorine. So chlorine forms +7, +5, +3, +3, then +2, +1. So here are +3 and +1. So here it is +6. So hence they gave a new name. There is a lower This is a lower and it is higher to this. So it is called per and it is called ATE, manganate and permanganate. So these are the radicals necessary for you in your plus 2 label, and we will be then using writing this. Then in few radicals, this oxygen also combines with boron and group 3 elements. I told you in group 3 elements they form valence state 3. So these are the radicals. The boron combines with, in boron we have the 3A of the periodic table, which is 13. In long form periodic table it is 13. In modern periodic table it's 3A. We have the boron, aluminium, gallium, indium, thallium. So we are interested in boron and aluminium. So oxy anions of boron and aluminium. So boron forms combines with oxygen to form BO3 minus 3. This is called borate. So somebody may come, sir, how you got this? Now boron is group 3A. So it's BO3 minus 3. If you take then C, boron is X. So X minus 6, X minus 9 is equal to minus 3. So X minus 6 is equal to minus 3. So X is plus 3. So boron is using plus 3 oxidation state, higher oxidation state, because the group elements of group 3 will only exhibit plus 3 oxidation state or valence state. They will use only plus 3 valence state. So borate. Then it was found, it formed another radical, BO2 minus 1. BO2 minus 1. When they found another radical is formed, BO2 minus 1, they called metaborate. They gave a name to this as metaborate. They gave a name as metaborate. Now if you come to aluminium also forms AlO3 minus 3. It is called aluminate. And it forms AlO2 minus 1 aluminite, or it's called meta-aluminate. Why I am writing this, children? You will be having boron family in your class first year. In 11th class, in your syllabus, all ICSE, CBSE, CHSE, all the boards, they have boron family. So you have 2 elements in your syllabus, chemistry of boron and chemistry of aluminium. So if you learn now the 2 important radicals, meta-aluminate and aluminate. Boron forms borate, aluminium forms aluminate. It forms BO2 minus 1. You see, I tell one sentence, I have told you the elements belong to a group exhibit similar physical and chemical properties. Being boron and aluminium are placed in the same group of the periodic table, they will exhibit similar properties. Now let's come to phosphorus, because we have also in our syllabus the nitrogen family. We will be having nitrogen family, and nitrogen, the 2 radicals I told you, nitrate and nitrite. Phosphorus forms PO4 minus 3. It also forms PO3 minus 3. So this is called phosphate and is called phosphite. So these are the radicals we have discussed. So for knowing the oxy anions and how to get the formula of oxy anions and how to get the charge of the oxy anions without remembering the charge, we just looked at the periodic table, which group of the periodic table they belong to, and the moment we know the 8 minus group number, is the number of the charge, and anion you write minus. If it is a cation, you write plus. Now with these concepts, now let's come to write the formula of chemical compounds. Today's class we will be basing on the formula of chemical compounds. So what the chemical compound contains? It contains the basic radical and acid radical. It will have the basic radical, it will have the acid radical. Two elements or more than two elements may be there also. So here the basic radical, and let us first go from simple, then you go to compound, then you go to complex compound. So now let's come to formula of the chemical compounds. What you write? Now write the what the principle we will use. Write the basic radical. Write the basic radical first with its charge. With its charge. What is that? B plus N. I am writing B is the basic radical and charge is the plus N. Then write the acid radical. Then write the radical with its charge. With its charge. That is what? A minus M. A stands for acid radical, B stands for basic radical. So the formula B will be what? B will be combined with M, A. Now B is the basic radical, will combine with acid radical to form the compound. B is what? Plus N is the basic radical, will combine with the acid radical to form the compound. To form the compound. So what will be charge of the compound? The charge of the compound will be 0. What is the charge of the compound? Charge of the atom is 0. Charge of the molecule is 0. Compound always exists as what? A molecule. So what is the charge on the molecule is 0. So these two will combine. Then how to write the formula of the compound? So what we do to write the formula, I will first tell you how to write the formula, then I will explain you why I did like that. So first what I will write? B plus N, then I will write basic radical, then the acid radical M. So then I will get M to this place and N to this place. They call crisscross. There is the criss and there is the cross. We take the N to A and M to B. Then what this will become? This will be B plus N you have. Who came here? M. And it is minus M. Who came here? N. So what is the total charge on B? Total charge on B will be what? Plus N into M, it is plus Mn, and total charge on A will be how much? Minus M into N, that is minus Mn. So total charge of the basic radical is plus Mn, and total charge of acid radical is minus Mn. So what will happen? Now if you add these two, then they become what? Charge 0. Why I did this? Now I told you one sentence, substances. Remember this sentence. There is a sloka of Gayatri of inorganic chemistry. Substances when react by their equivalences. Substances when react by their equivalences. So one equivalent of B will combine with one equivalent of A. So the total charge, so we got the M here, total M plus N, and with all the M here, N here, so the formula of the compound will be now what? What is the formula of the compound? The formula of the compound will be BMAN. So this is the way. First we write the basic radical with its charge at the top, then write the acid radical with the charge at the top, then exchange the number of the charge, exchange the not the charge, number of the charge. So we B plus M, we got the M here, and N we got here. So here total charge is plus N into M plus Mn, and here minus N and Mn minus Mn plus Mn minus Mn 0. So B atoms, M atoms of B will combine with A atoms of N to form the molecule BA. So what the formula now we got? We got first we write the basic radical B plus N, then we write the acid radical M. So the formula will be, we will get M here, BMAN. So this is the method we use to write the formula of any chemical compound. We first write the basic radical with the charge on the top, we write the acid radical with the charge on the top, then crisscross them, we got BMAN is the formula for the compound. So let us take a monovalent element, sodium, and try to form the compound with different acid radicals. So let's take sodium. We'll write now sodium. We'll write the basic radical. We take the sodium, fluoride. We want to write the formula for sodium. Sodium is Na plus F is F minus. So this will be the formula will be NaF. We are writing the name of the compound, and then you write the basic radical and acid radical, then we are crisscrossing them. Then we suppose we got sodium bromide, sodium formula Na plus, bromide Br minus, so this will be NaBr. Then we'll come to sodium oxide, Na is plus and O is minus 2, so minus 2 will come here and plus 1 will go here, so this will be Na2O. Now sodium peroxide, so sodium is plus 1 and peroxide is O2 minus 2. Peroxide is O2 minus 2, so minus 2 will come here, Na will go there, so the formula will be Na2O2. Now let's come to sodium sulfide. Sodium plus 1, sulfide minus 2, 2 will come here, Na will go there, so the formula will be Na2S. Let's take sodium nitride. I am coming to group 5 now. Sodium nitride, Na plus 1, nitride minus 3, and the form 3 will come to this place, this will go to this place, so we'll have Na3N, sodium nitride. I'll come to sodium phosphide. Na plus, then P minus 3, so 3 will come to this place, Na3P1, Na3P, like this. So we wrote the simple, we take a simple radical and we wrote the formulas. Now we'll come to oxy anions. Take sodium, or let us take a divalent radical, basic radical, and write the formula, and oxy anions and write the formula. Suppose let's take barium. we'll take barium oxide. Barium oxide. So it is barium is Ba plus 2 and oxide O minus 2. We will write BaO because both will cancel, will become BaO. Now barium phosphide. Barium phosphide. So barium Ba plus 2 and phosphide is P minus 3. Barium plus 2, phosphide minus 3. So 3 will come to this place and 2 will go to phosphorus. 3 will come to barium, 2 will go to phosphorus. So this will be Ba3P2. Ba3P2. Now let's me go to some oxy anions. Suppose barium perchlorate, barium perchlorate Ba plus 2 and chlorate ClO4 minus 1. So 1 will come to barium, 2 will go to perchlorate. So this will be Ba1 and ClO4 minus 2. Always write in a bracket. Why? Now this 2 will go to whole perchlorate. So BaClO4 twice. Barium chlorate. Barium chlorate. Barium chlorate. This is Ba plus 2 ClO3 minus 1. So 1 will come to this place, this will go to this place. So this will be BaClO3 twice. So then let me take barium phosphate. Barium phosphate. Barium is plus 2 and phosphate is PO4 minus 3. So 3 will come to barium, 2 will go to phosphate. So this will be Ba3PO4 whole twice. Now let's take a trivalent radical, aluminium. Aluminium sulfate. Aluminium sulfate. Aluminium is Al plus 3, sulfate is SO4 minus 2. So 2 will come to aluminium, 3 will go to sulfate. So the formula will be Al2SO4 thrice. Bas. Now we'll come to aluminium. Aluminium chromate. Aluminium chromate. Al plus 3 CrO4 minus 2. So 2 will come to aluminium, 3 will go to chromium. So aluminium twice, then chromate thrice. Like this. So very easy to write the formula. Once you write the basic radical, then write the acid radical, write the charge of the basic radical at the top plus n, write the charge of the acid radical minus m, then formula will be BMAN. So that the principle we have taken and wrote the formula. So at home I am giving a home task. You take a home task here. What you do, you take potassium and write formula for all acid radicals, all anions, that is single radicals, then simple radical and compound radical. Then you take calcium and write the formula for all anions, and then you take aluminium and write the formula for all anions. You make a practice of this. This will help you a lot, and whenever you are writing, whenever your sir will be teaching in the class or you will be writing the answers, you will not do any mistake for this writing the formula. So now with this chemical formula, I will come to now what are acids, what are bases, what are salts, and how to write their formula from the basic radical and acid radical. So my point is, all the chemical compounds will now write the formula of acids, bases, and salts. These are the language I am teaching you children, not the chemistry acid base salt chapter. There is in chemistry a special chapter called acid base salt. We will read acid base salt separately, but I am teaching you how to write the formula for an acid without remembering it. We will not remember the formula of acid, we will not remember the formula, we can write their formula from this. So let's come, what is an acid? We will come to definition of acid. You have read in schools. Amla joda padhithilo tame Odia medium school pila mane amla boli padhicho, our English medium CBSE ICSE you have read acid. What are acids? The acids are the compounds. Acids are the compounds. Acids are the compounds which contain replaceable hydrogen atoms. Which contain replaceable hydrogen atoms. Then what is a replaceable hydrogen atoms? Those hydrogen atoms which are replaceable, which are replaced by metal atoms, which can be replaced, better word will be which can be replaced by metal atoms. Metal atoms are called replaceable hydrogen atoms. So this was the very first preliminary definition, replaceable hydrogen atoms. Primitive, you can call them, primitive definition. But later on, when the chemistry developed, then how this hydrogen atom is present in the acid? How is present in the acid? So it is present as H plus. So then the chemistry definition came for acid, those compounds which donate H plus ion are called as acids. So this replaceable hydrogen atom comes out of the acid as H plus, comes out of the acid as H plus. So then the definition came for acids. Those compounds which donate H plus ion in their aqueous solution, means a solution prepared in water. An aqueous solution means a solution prepared in water is called aqueous solution, are called as acids. Means what? The formula H is there, X is there. This is the acid. HX is the formula for acid. What you do? We add H plus, we add water. When we add water, this H plus comes and goes to water. I taught you hydronium ion, so H2O plus H, so this will form H3O plus hydronium ion and X minus. So what is this? This is called acid radical because it comes from acid radical, and this is called hydronium ion. Hydronium ion. I talk to you, when water combines with H plus, it forms H3O plus. This H3O plus is called hydronium ion, and X comes from the acid. This X comes from where? From acid. And what it contains? A charge. So when an atom contains a charge is called what? Radical. It comes from acid is called acid radical. Janti ame tap water. The water coming from tap, a tap water. The moment you take same tap water, put into a bottle and keep in the fridge and get out of the fridge, the water is a freezed water. That becomes a what? Freezed water. Now you take the same water, boil it or warm it. That is warm water, not tap water. Because you are getting it from a warm condition, so you are warm water. So here also HX is the acid. It contains H plus and X minus. The moment we add water to it, it gives this H plus to water. So those compounds which donate H plus ion in their aqueous solution, means in water. So water will combine with H plus to form what? Hydronium ion, and this forms acid radical. What is this happening? Now this is a reversible sign we write, because this will combine these two and they combine again, produce this. So this formula is called as dissociation. This is called as dissociation. This process is called dissociation. We take the food and eat. The process is called digestion of the food. Digestion of the food is called dissociation. So then if you come from this, acid radicals will combine with H plus to produce the acid. How the acid is formed? So what is the property of an acid? Acid turns blue litmus red. What the test for acid? Acids turn blue litmus red. Then how to write the acids turn the blue litmus red? How will you test the acid? You will take acid, put a blue litmus paper, this will turn red. Then that is called acid. Now my point is, what I am going to teach you today, I want to write the formula for acids. So all acid radicals, all acid, or you can acid radicals, all you can acid radicals combine with H plus ion to form an acid. To form an acid. So our acid radicals are of two types. Acid radicals are two types. So all ID radicals, all ID radicals combine with H plus ion to form hydra acids. To form hydra acids. So all acid radicals combine with H plus ion to form acid. So if I write like this, I have the acid radical. This acid radical will combine with whom? H plus to form the acid. So this acid will be of two types. Now why? This will combine with ID radical. This will form hydra acid. Hydra acid. And some acid radicals, they have oxy anions. So when it will combine with oxy anions, then it will form oxy acid. So our acids will be of two types. One are called as hydra acid, and they will form oxy acid. Hydra acid and oxy acid, all ID radicals. So let's come to write the formula for hydra acid, and the name we will write. So now we will take H plus, will combine with F minus, fluoride. What is this? Fluoride. this will form HF. So this is called hydrogen fluoride. We can call as hydrogen fluoride, compound name, or hydrofluoric acid. Hydrofluoric acid. H plus will combine with Cl minus, chloride. Cl minus is chloride. Will form HCl. It is hydrogen chloride. This compound name is hydrogen chloride, and since it's an acid, we call this as hydrochloric acid. Children, now you can know you are using HCl, how the name came. You were in a confusion state. Now you could know how we got the name. Now let's come iodide. We have I minus combined with H plus. So this forms Hi. This is hydrogen iodide. Hydrogen iodide or hydroiodic acid. Hydroiodic acid. So all ID radical forms iodic acid. Surely we'll have a Cn minus, H plus. This comes HCN. Compound name is hydrogen cyanide. Compound name is hydrogen cyanide, and as an acid there is hydrocyanic acid. So this is very easily, now you are knowing the formula of, you are writing the formula of the acids. Very easy. So all ID radicals combine with H plus ion to form hydra acids. The name of the hydra acid, they end in iodic acid. So hydrogen fluoride, hydrogen fluoride, hydrofluoric acid, chloride, hydrochloric acid, bromide, hydrobromic acid, iodide, hydroiodic acid, cyanide, hydrocyanic acid. So next class I will teach you, take the oxy anion and combine them with your H plus, and I will write the formula for oxy acids, so that you will not be remembering the formula of the acids, and you can easily write the formula for acid and how to get the formula for acid. Once you learn, you can use your mind and get the formula of many inorganic compounds. We will not remember the formula, we can write the formula by ourselves. Thank you so much for listening the class. Very soon we'll start the second class. There I will teach you how oxy anions will combine with H plus and to form the oxy acids. Thank you very much.